Okay, so today we're going to move on with a different type of question about congruent triangles. So in the homework that you did previously, you were just asked to identify if triangles were congruent and just give a reason. And your reason was RHS, SAS, ASA, that type of thing. Now this time we're going to make it a little bit more mathematical in that when we're given two triangles, like as in this question here, we're being asked to prove that the triangles are congruent. So when they say to prove that two triangles are congruent, we need to give a more rigorous reasoning around why they are congruent, using the same one of our four, RHS, SAS, SSS, ASAs. So I'll show you how to do it. How we're going to start with this example number 1, and then we're going to do question 3 from your book also. So question 1, first of all, it says ABC and DEF are two right angle triangles. ABC, DEF, okay. Equal sides are marked. Prove that these triangles are congruent. So we know straight away that from looking at it, we're going to use the RHS because we've got right angles that are equal in both of them. They both have their hypotenuse, which is equal, and they have another side which is equal. So RHS is the reason they're congruent. But because they said prove, we actually have to write down why each part of the RHS is true, and then just say therefore they are congruent. So here's how we start. It's the triangles ABC and DEF. So I always start by just writing triangle ABC on one side and then triangle DEF on the other side. Okay, then the next thing we're going to do is we're going to take each of the R, H and S separately. So if you want to start, it doesn't matter the order we do the three of these in, but just for the sake of it, we'll do the right angle first and then the hypotenuse and then the other side. So the angle in the triangle ABC, which is the right angle, is the angle ABC. And we write it like this, and we write it underneath this. We're going to form a type of column underneath the triangle ABC part. We write the measure of the angle ABC, so it's B in the middle. B is where the right angle is, the angle ABC. The measure of the angle ABC is equal to whatever the right angle is in the triangle DEF. So what is it? It's the angle DFE, or if you like EFD, whichever you prefer. So I'm going to write DFE. So it's equal to the measure of the angle DFE. So we write that first for each of the three items in our, whatever it is, RHS or SAS or whatever we're using, but then we must put a justification in brackets afterwards each time. Now in this case, all we're going to write is 90 degrees and given. And by given, what we're saying is they've told us it in the question. It's been given to us. We don't have to give some kind of, we didn't have to work it out in some type of way or prove it using geometry or something. It was given to us. It was told. And for this first example, it's going to be pretty much given all the way down. And in the next example, we'll show you ones without given. Okay, so that's the right angle. Next thing is the hypotenuse, and the hypotenuse on the triangle ABC is this line segment AC. So we write next the length of the line segment AC by using these straight lines here is equal to, and this is the length of the line segment DE. And again, because we're going to use RHS, we'll just say they're the hypotenuse. And again, it was given. We were told it by our diagram here. Okay, and lastly then we have on this triangle first, because we're always doing this one first on the left-hand column, we have the length of the line segment AB is equal to the length of the line segment DF. So the length of the line segment AB is equal to the length of the line segment DF, and again it was given. Okay, and then lastly, once we have our three things for RHS, or if it was a different one we were using for SAS or SSS, we'll have three things. The last thing we'll do is then we'll say that the triangle ABC is congruent to, with the three lines across, the triangle DEF, and in brackets our justification is RHS. Oops, RHS. Okay, so again, a few things to point out. All of these items here, I kept them in a row. These are all, that's an angle and two sides from this triangle. So I kept everything to do with that triangle on this side. And this angle and these two sides are from this triangle DEF. So I kept everything to do with the triangle DEF on this side. Okay, and the last thing I will say as well is that's it, that's done. We've proven that they're congruent because of RHS. In some questions, they might ask you an extra little thing. They might say, prove that they're congruent and therefore prove that BC is equal to EF. Well, all you have to do is add an extra line saying, therefore, what is it, BC is equal to EF. Because if they're congruent triangles, then all of their sides and all their angles must be equal. So your justification here is congruent triangles, because you've just proven that. Okay.